Imagine a single grain of sand. Hold it in your hand. Feel how tiny it is. That grain of sand is Earth. Now scale up. Keep going until our entire Milky Way galaxy, with its billions of stars and planets, looks like a single tiny molecule floating in a vast, dark ocean. When you zoom out this far, the universe starts to look very different. The rules change. And hiding in the dark is a secret. Out there, floating in the deep void, is a structure so massive, spanning over 10 billion light years across, that it shouldn't exist according to our current laws of physics. By the end of this video, you won't just see the universe differently. You'll understand the invisible web that holds absolutely everything together. To understand the impossible, we first have to understand the normal. Let's start at home. This is our solar system. It feels incredibly huge to us. It takes light from the sun, the fastest thing in the universe, about 8 minutes just to reach Earth. For humanity's fastest spacecraft, like the Voyager 1 probe, it has taken nearly 50 years just to reach the edge of our solar neighborhood. But in the grand scheme of things, our solar system is practically microscopic. Let's level up. If we zoom out past the sun, past the nearby stars, we find our local city, the Milky Way galaxy. It is a stunning, swirling disk of light, home to somewhere between 100 billion and 400 billion stars. It is so vast that if you wanted to send a text message to the exact opposite side of the Milky Way, traveling at the speed of light, it would take 100,000 years to deliver. It is massive. But galaxies do not like to be alone. Gravity, the invisible glue of the universe, pulls them together into neighborhoods called galaxy groups. We live in a neighborhood called the local group. It is a cluster of about 54 galaxies, including our massive neighbor Andromeda. But gravity is never satisfied. If we zoom out even further, things start to get weird. Galaxy groups clump together to form massive clusters, and those clusters clump together to form superclusters. And this is where we meet our first true cosmic giant. Welcome to Laniakea. In Hawaiian, Laniakea means immense heaven. This is our supercluster. It contains over 100,000 galaxies, stretching across 520 million light-years of space. For decades, scientists thought we just lived in a random, scattered clump of galaxies. But when they finally mapped the way these galaxies were moving, they realized they were all sliding along invisible threads of gravity, flowing like water down a cosmic drain. But look closely at how they are moving. All of these 100,000 galaxies, including our own Milky Way, are being pulled toward a single mysterious point. We call it the Great Attractor. It is a gravity source so incredibly powerful that it is dragging entire clusters of galaxies toward it at over 1 million miles per hour. What is it? We don't exactly know. It sits in a region of space that astronomers call the zone of avoidance. The thick gas, dust, and brilliant stars from our own Milky Way galaxy block our view, essentially blinding our telescopes when we try to look in that direction. We are falling toward a giant, and we can't even look it in the eye. But as huge and terrifying as the Great Attractor is, it is just one single knot in a much, much larger net. Let's level up again. If you pull back hundreds of millions of light years, galaxies stop looking like individual objects. They stop looking like swirling disks of stars. Instead, they look like glowing water droplets clinging to the threads of a spider's web. This is the cosmic web, the absolute largest network in reality. Look at this for a second. When scientists mapped out the deep universe, they found something shocking. The structure of the universe looks almost exactly like the microscopic, neural networks inside a human brain. The way galaxies cluster and branch out perfectly mirrors the way brain cells connect. It makes you pause and ask, is the universe actually an organized organism? Are these glowing strings of galaxies just the nerve endings of something we are far too small to understand? These cosmic strings are made mostly of dark matter. Dark matter is an invisible, mysterious substance that we can't see or touch, but it acts like a heavy skeleton for the universe. Its gravity pulls normal matter together. Where the dark matter threads cross, massive structures of light form. And where the threads don't cross, we find the opposite. We find voids. You can't have a web without empty spaces between the threads. If you look at the cosmic web, you will see vast, terrifying patches of pure nothingness. The most famous is the Boots void. It is a spherical region of space nearly 330 million light-years wide. It is so terrifyingly empty that if the Milky Way had been placed in the center of the Boots void, we wouldn't have known other galaxies existed until the 1960s. But back on the glowing threads of the web, things are getting crowded. This is where we find the Sloan Great Wall. It is a giant wall of tightly packed galaxies stretching 1.3 billion light-years long. It's so big it completely takes your breath away. But science tells us that structures like the Sloan Great Wall should be the absolute limit. According to our math, nothing could be bigger than this. Except, we found something bigger. The universe, it turns out, is hiding monsters in the dark. In physics, there is a golden rule called the cosmological principle. It states that if you zoom out far enough, the universe should look totally uniform. It should look even, smooth, and perfectly balanced. Just like a well-stirred cup of coffee, there shouldn't be giant clumps of stuff in one place and totally empty space in another. But then, scientists looked deep into the distant universe and found the giant arc. The giant arc is a massive, sweeping crescent of galaxies spanning 3.3 billion light-years across the sky. It is so ridiculously big that it completely shatters the cosmological principle. It throws our neat, uniform physics straight out the window. It proves the universe is clumpy, chaotic, and unbalanced. But the giant arc is not the climax of our story. The real problem, the ultimate giant that absolutely shouldn't exist, is hiding even deeper in time and space. To find it, scientists weren't looking for galaxies. They were looking for gamma-ray bursts. These are the brightest, most violent explosions in the universe, happening when massive stars collapse into black holes. Because these explosions are so bright, they act like cosmic flashlights, illuminating the deepest, darkest corners of space. By tracking these bursts, astronomers accidentally illuminated a monster. Meet the Hercules-Corona Borealis Great Wall. It is the single largest structure ever discovered in the known universe. It is 10 billion light-years across. Let that sink in for a moment. 10 billion light-years. The entire universe itself is only about 13.8 billion years old. According to every single law of physics we currently have, there simply has not been enough time since the Big Bang for gravity to drag enough material together to build a structure this insanely massive. It would be like watching a toddler build a full-size skyscraper out of toy blocks in 5 minutes. It shouldn't exist. Yet there it is. A 10 billion light-year wall of exploding stars and clustered galaxies glowing in the dark, silently mocking our understanding of reality. We started this journey holding a single grain of sand. We traveled through the massive swirl of the Milky Way, fell toward the unseen Great Attractor, traced the beautiful, brain-like filaments of the cosmic web, stared into the terrifying emptiness of the Boots void, and finally stood in the shadow of a 10 billion light-year structure that breaks the very laws of physics. We're a tiny piece of an endless puzzle. We live on a microscopic speck of dust, inside a molecule, trapped inside a glowing web that stretches out into pure infinity. Every single time we build a better telescope or create a new way to measure the stars, the universe proves that it is stranger, wilder, and more majestic than we ever could have imagined. So I want to leave you with this final thought. Does knowing our true place in this vast cosmic web make you feel small and insignificant? Or does it make you feel like you are a part of something much, much bigger? Let me know your thoughts in the comments below. Thanks for exploring the cosmos with me. I'll see you in the next one.